Hello explorers and welcome to another video. Today it's that time of the year again. We are having another Java point release. It's Java 21. The next long time supported version is 23. So we are a bit on the way to there. But every sixth version is the long time supported one. So this is just another point release. And I have called this one Finalized abbreviation because it's finalized a lot of things. A lot of things are actually done and ready for production. You can start using it. And a lot of things are abbreviated for less typing and in some cases less readability. In this release date is about the 19th of September. But now it is in the wrap down phase and no new features will be added. So now we can talk about it. So let's jump into it. The first one that we want to talk about is JEP 404. The General Generational Shenhua Experimental. So Shenhua is one of those garbage collections that has been in the Java version already for a couple of versions, and this one is a way of trying to make it generational. So Shenhua should be a low latency and less GPU memory heavy version of the GC. But it didn't have this generational feature where you have a young and an old, and where you have some part of the memory that is newly written objects and some of them that are older. So they are trying this kind of things out. You can read more about this. Yep, I didn't look that closely into it, but they are trying to make this specific functionality generational, which meaning that you have one memory area with new objects and one with older, or multiple. So the next one is also a generational one, the ZGZ. And ZGZ is, I think, pretty much zero downtime. It should have a very, very, very small window where it actually has to break execution and clean up memory. So it has a totally different use case than many of the other garbage collections, because you could have a stop time of up to, let's say, 12 milliseconds to remove objects. This has the requirements that you don't have more than a millisecond of downtime in each cycle, which is a totally different use case, of course. So they are trying to make that generational as well, and this is also somewhat experimental and the trial version, not something that you can just use today. Next up, we have the string templates preview. So this is another preview. We have already had one of them, but there's this more clarification after they found a bunch of different issues with string templates and SQL statements, JSON objects, and so on, which they have tried to clarify and make it easier. The string template is a little bit different from other languages, so let's look at some examples. Here we have an HTML example, and we can see my web page, hello world, and it's a title and a text, and then you have backslash brackets, these kind of curly brackets, and then the name of the variable in the template, and you are using the object called str dot and then the string. In this case we are using this longer format of a string, so three quotation marks in order to have a longer string relationship here. So we have the str, and then we actually have one more. We have the fmt, which is a formatting structure. So in this case we have a rectangle with a bunch of information, and then we can use the different values here to format our string. So down here we have, for instance, I think 12 characters of the name, followed by let's see, 7 numbers, followed by 2 numbers as the decimal point. So this is a way of formatting your information so it's readable on screen. So yeah, that's an interesting one, that you can have this kind of formatting string built into your string template. So I'm really looking forward into more iterations of this and seeing where it goes. But so far I think they are on a good track. I'm not really sure that I like this FMT with big letters like that. So that's some kind of constant class functionality. But I haven't used it before, so it's free, I guess. Just thinks it looks a little bit strange. Next up, let's jump to JEP 431, which is sequenced collections. And before we had sequence lists. We had lists, we had, I think we had some sets that were also in sequence and so on. But they want a sequenced collection, so you can have more things that has a sequence. And the interface for that is pretty much, you have a collection and it extends to its sequence collection. And in this case, you can reverse the collection. So you have them in order, but you can have reverse order. You can add to the first and last element. So you put either at the top of the list or at the end of the list. So beginning or end. You can get values from beginning or end, remove values from the beginning and end. So it's a sequenced list where you can handle the data as a list. And you can also loop through them in that sequence, of course. Next up, we have sequenced map. So we don't really have that kind of functionality before. We had some strange version of a linked map or something like that you could use in order to have a somewhat of a sequence. But this is more of an interface that you could use a sequenced map. And in this case, it is reversible. As the other case, we could get the sequenced key set, the sequenced value, the sequence entry set. I'm not really sure why we need to have sequenced here. I think it could be good to just have key set, values, and entry set, and then we know that it's sequenced. I don't know what that keyword needs to be there. We can put first and last, and then we have get the first entry, get the last entry, and pull the first entry, pull the last entry, so we can actually remove an entry and get that entry out. So those functions are pretty powerful. So I like this interface overall, but I think they could skip this keyword of sequence on these methods, in my opinion. Next up, we have JEP 440, the record pattern. So let's look at an example there. In this case, we have an instance of function. So they have worked on this before, where they had a record which had a definition, and then you wanted to use it in some kind of structure like this instance of. And in this case, you can just say that this instance of point xy, then you can use x and y later on as usual. So I think this is a pretty clean interface, and they are rectifying it and actually saying that this is the one that we will release. So this is the finalized version if there is no real objections to it. So this is something you can use in 2021. Next up, we have the pattern matching for switch. Also one of those that have been going on for a long while. Now it's finally here. We can start using it. And what they ended up with was this kind of interface. So we have a switch statement, integer I, and then we write out the integer and so on. So we can use the type in order to inference what to do with the object. Really nice. Next up, we have 442, foreign function memory API. This is the third preview, so they're still working on it. To make the story very brief, we have functionality now to call a function or fetch some memory from an external source. So you could have a C program, or you just want a bunch of memory as a pure memory in the system, and you don't want to have objects and so on and garbage collection and all of that things. You want to actually have a foreign function and memory utilization. So this is a new API for that to make it a little bit easier. So it's a GNI with more memory management as well. It's very interesting, but they have been on it and I've talked about it in previous videos, so you can look more into that in those videos. Next up, we have unnamed patterns and variables, and this is a preview. This is one where you remove remove information where it's not needed. So this is a good one, where you have, let's say, something that is never used. You have a loop with an iterator and you don't use that iterator value, then you can just say that it's not something that I'm interested in. So this is a good thing for the reader as well to know that this is not important. So here is an example of a variable where we get 2 of the 3 variables in a point. So we don't care about the set value. And then we can say with just an underscore that this variable is not interesting. You can still fetch it and have it there, but for the reader, we know that that will never be used. Next up, we have an example of this, where we usually do this number format exception. I can see this as writing a functionality to say, is this a number or not? And then you never are interested in the formatting exception. You're just interested in could I do it or not? And in this case, you can just skip that information. And last but not least, we have the switch statement here. We want to know if this is a red, blue ball or a green ball or something like that in the box. So this is the reckon pattern again, but we don't really care about the variable. We will never use it. So we just omit it like that. And then we have the JEP for and this is the virtual threads. Virtual threads is really interesting. It was a part of Java back in the days, and then we went to real threads, which actually had a process ID in the system, using more system resources and actually using the systems for the threading functionality. But that requires that you pretty much have one process, a processor for handling that thread at any time, and you can't really have millions of threads. But with virtual threads, they are very lean. They don't use that much memory. They don't use compute resources. One processor or one thread could handle multiple of these virtual threads and so on. So you could actually create a long queue of things that should be handled on a virtual thread, and it will be faster than spinning up a new thread for each execution. So here we have an example for that. We have an executor with a new virtual thread per task executor. So this is a new kind of executor that we have. And then we will just submit a bunch of work to it like this. Here we have 10,000 threads that we will, or things that we want to use, and we don't need to close the executor down here. It's called implicitly, and it will wait for the execution to finish. So this is a quite good way of running these kind of things. So this is useful, something that I probably will use in my programming as well. Next up, we have JEP 445. So this is unnamed classes and instant main method. And this, they said, is for new users into the programming language. And what they are doing pretty much is saying, okay, we want to have Kotlin in Java, and we want to remove a lot of the structure because we are not asked to actually explain to people why the extra information is there. And in my case, I really like that Java is an expressive language, is a language that you have for reading, not writing. You generate a bunch of code, you create a bunch of structures and so on to make it easy to read later. If you, for instance, have a consultant work and you go in and write some code and then end that assignment and never goes back to it, you write a bunch of Kotlin code because that is fast and easy and you never need to read it again. Pretty much. It just something that you will throw away later. But if you actually want to read it like 10 years later, you need to have all the context and everything in order to understand what a function actually does. And Java is very expressive that way. And this is a way to strip away a bunch of that information to make it easier for new users. So in this case, here is a main function for Hello World. So they have stripped away the class information. It is implied. So you will need to read up and figure out what kind of class is actually defined here. What is going on? What will that class be named? How will I actually run it and so on? So there's a bunch of information around that. But writing a main function or writing a small script is just this small information here. So it's very similar to Kotlin. The only thing is that we have the return type like void. But we have stripped away the arguments. We have stripped away the class definition. We don't have any of the public static to actually say what kind of function this is and how it could be called, and so on. So yeah, it's a way of doing it. I'm not a fan, but it's if it's gonna be there, then it's gonna be there. I'm not gonna use it. Next up, we have scoped values, and this is the second preview, I believe. They have already had a work going on with this, but this is pretty much if you have a long time running service and you have somewhere something is happening, so you need a variable that will follow that thread through and do a bunch of things, but you don't want to send it as an argument because it's more integral to that thread's workload. So here we have an example. Let's say we have this server that has a scoped variable called a principal. So it creates a new instance of it. And then we figure out if this is an admin or a guest. And we set that level to a principal and then store that information in the principal. And then we create this scoped value where this principal is that principal. And then we will run some application handle with a request response, which means that we could send it into this framework, and this framework could do a bunch of work. And then at some point it tries to open a database here with a database access. And this is our code again. And then we need to have that information so we can fetch that principal from the server. And because we are in the same thread, it's available. So either if it's not, then we need to throw an exception, of course, but then we can use it in order to create a new connection. So if you have a large framework and you implement some parts and you still want to send information through, this is a great solution for that. Next up, we have JEP 448, the vector API. This is the 6th incubator. So they have been going on for this for a long while. I'm not sure if I had an example of it. No, I have talked about it in earlier videos, but this is another way of handling memory in a good way. So it's an API to handle a large amount of memory and fetching data from it. And then we have a really good thing. And I don't think there is that many installations left out there running version 22-bit Windows. So this port will, the removal of this port will make the code base a lot easier to read and will remove a bunch of things that is not interesting anymore. So at the moment it's deprecated. So in Java 21 you can still run Java 21 on a really old Windows installation. But going on in the future, we will no longer have that support. And I think it's a great thing. So I hope before Java 23 that this is just features that are removed. Next up, we have JEP 451, which is prepared to disallow the dynamic loading of agents. So in this case, they will throw a warning saying that you are loading an agent when you are running the program. And agents are stuff that looks into your Java while it's running and giving you some information. So for instance, in my case, I use a debugger that could actually go in and then read all the threads and the memory allocation that goes on to performance check and also figure out if I have any memory leaks or anything like that. And in this case, it could be run in two modes. Either you could just start it when the process is started and debug and so on, or you could connect to an already running service in order to fetch that information. And with this change, you will get a warning if you're trying to connect to a Java process that is already running. And it's a good thing for security. It makes things a little bit less useful. Some tools are less useful. But I think it's a good thing because it could actually lead to a lot of bad actors doing things with your system. So for now, I think it's a good change. You could, of course, still run this tooling by invoking the agent when you are starting the application, and then you will not have any problems with it. So overall, a good change. And then we have key encapsulation mechanism API. And this is an encryption API where you earlier had these kind of different ways of sending information through the network and sharing keys. And this key encapsulation is when you can have, for instance, a key that should be shared between two users. This is these kind of keys where you use it for large block encryption, to use the same key on both ends. And this mechanism is a really structured, specified way of sending that key over using private public key pairs. So this is a mechanism that has been in the crypto world for long. You could reach it through different libraries, but now it's going to be a part of the Java API going forward. And it's not a part of this version. It's still just a test, but I think it's going to be an interesting thing to have there. Having security features in the Java runtime is not a bad thing. And next up, we have structured concurrency preview. So this is a way to structure your concurrency. If you have, for instance, a web server and you call into it and then you want to do a couple of things at the same time but return the result back to the user. So it's not the use case where you have a thread executor and then you send a bunch of work to it and wait for the result. It's more when you have a couple of them that needs to be running at the same time in order to make the calls faster. So here is an example of that. For instance, you have a handle an execution from a user. You create this structured task scope, and then we will have two forked here. I want to find the user, want to find orders, and then we will join that scope again and then return the response when both of these have been fetched. So I think it's an interesting way of doing it for these kind of executions. The things I usually write requires a bunch of work to be done, and then you just want to put it on the thread pool and you don't really need to have this structured scope. But I think it's a good thing to have in the Java API. So that was everything. Now we have gone through what is new and what is coming in Java 21. I hope you found this interesting. Yeah, I hope you're excited for Java 21. If you have any comments or suggestions, please leave them down in the comment section down below. Are you excited about it? What kind of things are you most excited about? What things do you think you never will use? Give me any information that you have or any excitement in the comment section. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.